Hi, I'm Carmel Eve and I'm here to talk to you about securing your data with Azure Data Lake Store. We'll talk a bit about the benefits of using Azure Data Lake and about some of the common security practices that it supports. Enjoy! So, what is ADLS? So, Data Lake Store is a storage solution. It's based on Azure Storage, but it provides some extra functionality. And in this talk, I'm going to talk about how we can leverage both the Azure Storage functionality and the additional stuff provided by Data Lake to build out a secure data solution. I'll go through these a bit more detail in a second, but Data Lake provides many benefits as a storage solution. It's built on Azure Storage, so it provides almost all of the Blob storage functionality. It's performant, reliable, scalable, secure, interoperable, and with all of this functionality is still extremely cost effective. So Blob storage, some of you have probably used it, but it comes with a huge range of built-in features, most of which we'll talk about as part of this talk. But Data Lake is an extension of Blob storage, and the main difference is that it enables hierarchical namespace. So it allows for collections of objects and files within an account to be organized into a file structure like that in the computer system. So you can have nested directories and subdirectories, and this means you can atomically control the entire directory rather than individual files or blobs. So in Blob storage, I know that when you go into the sort of storage explorer and you look at a Blob storage, you can see directories within that, but those are actually like virtual directories. So the blobs aren't actually organized into subfolders. It's just that through naming conventions, you can kind of set up virtual directories. Whereas in Data Lake, these are actually organized into subfolders and you can treat each folder as a whole. Whereas in Blob storage, still under the covers, this is treating each blob completely individually. So you get a huge benefit from that, as we'll talk about soon. So alongside this, Data Lake provides the ability to assign access control lists to files and folders within the folder structure. So it means you can have really fine-grained permissions over different silos of your data. So you can build up a really complicated permissions model inside of a single data lake. There is also support for atomic renaming transactions, which provides additional reliability, as we'll see in a bit. And all of this comes with only a slightly increased cost, which we'll, again, dig into a bit more in a minute. I've put a star here because some blob features aren't currently included in Data Lake, and usually these are the new features which are yet to make it through to the hierarchical namespace enabled storage accounts, but so some of these, as you can see here. So since I first wrote this talk, which seems like quite a long time ago, there have been quite a lot of updates to blob storage. And some of these are supported for ADLS, some of these aren't, but all of them are very much on the roadmap to be added into support. So the first one I want to talk about is that they've introduced soft delete functionality at both a container and a blob level inside blob storage. It protects your data from being accidentally deleted, as it means that the data can be recovered up to a specified retention period. This is currently enabled at a container level in Azure Data Lake, but not at a blob level. So support for soft delete for blobs is very much on the roadmap, but not currently there. In blob storage, they have also introduced immutable storage, and this is fully supported in Azure Data Lake. So this means you can now store data in a write once, read many state. It's a huge advantage when storing business critical data, because it means that you know that that data hasn't been edited and also can't be deleted up to, again, a specified retention period. So this can even be like a compliance requirement for certain types of data, so it's a great advantage of using Azure Storage. So there are also two features which aren't actually in ADLS yet at all. These are pretty new features and, again, very much on the roadmap. But so these are blob versioning restore and the change feed. So blob versioning restore means that you can store up to a retention period the old versions of your blob, and you can restore these. And this is a great feature because it means that you can recover to any state over the past, however long you want. And it so this is a huge advantage for recoverability. And the other one is the change feed, and this again means that you have this a huge advantage in terms of recoverability, because it means you have a full audit log for everything that's happened in your blob storage over the past however long. So yeah, as I said, these currently aren't supported by ADLS, but hopefully we should be seeing them in the very near future. So I thought I'd just quickly show how you set up a Azure Data Lake account in the portal. So here we're just creating a normal storage account. I assume most of you are probably familiar with the Azure portal. If not, this is what it looks like. So we're just creating a normal storage account. We're setting up a resource group for that storage account and setting up the account name. You can see at the bottom there hot and cold storage. So in Blob storage you have multiple tiers of storage. Some hot storage is for data which is accessed regularly, cold storage is for data that isn't accessed regularly, and there's a price difference between storing data in those two ways. That gives you quite a lot of flexibility. We can also see here, so soft delete, which is one of the features I was talking about previously, which has been enabled for Blob storage. And this is the important bit. So when we are defining a data lake storage account, all you have to do is check that box, and then you will enable hierarchical namespace. But we can see now that soft delete is no longer, we can no longer turn it on. That's because it's not yet supported, but yeah, hopefully be seeing that soon. So that's all you need to do to create a data lake store. When we press create, it should submit deployment. And once that is finished, we should be able to, there we go, go into the resource and have a look inside Storage Explorer. In the containers, so this is usually where Blob storage is, but we can see that we can create a file system. This is different to Blob storage. Usually this would just say container, but yeah, so if we create a file system and we then go into that, we can then create new folders within that file system. And as I said, this is actually creating subdirectories within the file system, and you can create child folders and build up a complex folder structure from here, from the portal. You can also do this in Storage Explorer. Cool, so and sort of right, so talk about some of the other benefits. So in terms of performance, we've talked about how ADLS supports our hierarchical namespace. This means that data can be organized into a fast system-like structure, and this means we can organize the data in order to reduce the amount of data which needs to be queried and increase the performance of queries that you need to run. So you can partition the data as you want and only query the bits that you actually are interested in. So that's really good. Azure Data Lake Storage also supports high throughput for I/O intensive analytics and data movement. It's like purpose built for big data analytics, and many of the big analytics frameworks like Spark and Hive, they have an explicit assumption that the underlying storage looks like a file system. So yeah, this supports that. And atomic rename is actually a really big part of this, because a lot of these frameworks work by creating a file, a temporary file to do the write to, and then once that write is finished, they'll rename that file. Obviously, if a rename operation involves sort of moving files and deleting files, then that's going to have a huge performance impact on your solution. In ADLS, rename is just an atomic metadata operation. So this supports the Spark and Hive model of like renaming files once the write is finished. This is so that you don't get into a state where you have half-written files which are persistent in the system. So this supports this, and it means that it can greatly improve the performance of these big write operations. So then the next sort of benefit we had on the list was reliability. So reliability, so these are all features of Blob storage. You have a lot of options when talking about reliability of Azure storage. So the first of these, locally redundant storage, means that your data is copied 3 times within a single data center. So this protects you from sort of failures on like a single rack within a data center, but not from kind of data center whole outages. So this generally isn't recommended for production workloads. But then you have zone redundant storage. So zone redundant storage means your data is copied across 3 availability zones within a region. So this means 3 locations with separate power, cooling, and networking. This means that so within you are then protected from failures within sort of a single data center. So if the power went out of a data center, you'd be protected from that. But you are still for things that happen on a sort of location scale, for within a region, you still might be affected. So then we have geo-redundant storage. So geo-redundant storage copies your data 3 times within a single data center within a primary region, and then copies that data once to a secondary region. So you're then protected from geographical failures. And then finally, you've got zone redundant storage. So that copies your data within 3 availability zones within the primary region, and then a single availability zone within the secondary region. So you've got a lot of options and a lot of flexibility when defining the reliability of your data. And these are all fully supported in Azure Data Lake and gives you a high level of confidence in sort of the reliability of your storage solution. So the next thing is scalability. Well, classically, there were storage limits imposed by Blob storage, which also applied to ADLS. I think these are about 5 pebibytes, and a pebibyte is 1024 to the 5 bytes, which is about 12% more than a petabyte. However, last November, it was announced that we will now be able to chain Blob storage accounts together. So this means that we can continue past those limits. It essentially means that storage is infinitely scalable because we can just keep connecting more storage accounts and scaling the solution. Alongside this, a lot of big data analytics platforms like Spark and Hive, which I already mentioned, are increasingly relying on linear scaling, so being able to add more nodes to scale out your compute. To increase the processing speed like that, it means that you need to also be able to scale storage linearly. And the way that elastic scaling in Blob storage works is that there's no limit on the amount of read or writes that can happen at a given time. So this supports that model of linear scaling. The hierarchical namespace features of ADLS also allow isolation of data, which means that you can further parallelize the processing and increase the scalability of the system. So I'm not going to talk about security yet because we're going to come back to this shortly as it's the focus of the talk. I thought I'd give it its whole own section. So yeah, to be continued to that. Right, so tooling and interoperability. So there's a new-ish version of the Blob Storage SDK called the Multi-Protocol SDK, and that can also be used in Azure Data Lake. This SDK handles all of the buffered reading and writing, handles retries for you in case of transient failure, and it can be used to efficiently read and write data in ADLS. So it's in the Azure Storage Blobs NuGet package. There are a few limitations around the multi-protocol SDK in terms of ADLS in controlling the features which are specific to ADLS. For example, access control lists can't be controlled and atomic manipulation is impossible. But there is actually a separate SDK under the Azure Storage Files Data Lake namespace for managing all of that. So between the two, you can do most of your sort of automated, all of your automated management of your data lake. But the fact that ADLS can be accessed through the common SDK means that anything which integrates with Azure Storage can also integrate with Azure Data Lake. So the integration of systems which already rely on Azure Storage is really easy. So in terms of integration and interoperability, that's a really great thing. Alongside that, I've talked a bit about the fact that ADLS allows you hierarchical namespace configuration and how that supports Spark and Hive and other analytic frameworks. I think specifically good to call out that Spark specifically has an assumption when you're partitioning things by date of a expected file structure. And Azure Data Lake allows you to support that file structure, and therefore you can then use all of the sort of optimized partitioning logic inside of Spark to look at time partitions. And so ADLS allows you to sort of support Spark, the optimized parts of Spark out of the box. And also finally, there is an option of integrating with other services in Azure, such as Event Grid. This means you can sort of send diagnostic notifications straight to Event Grid and then integrate through Event Grid with other services like SignalR and or analytics, and other subscribers can then perform data analytics over the events from your data lake. So some great interoperability and hopefully more coming. And finally, I just want to talk about cost. I wanted to mention the fact that, so I've already mentioned the fact that ADLS is built on one of the cheapest available cloud storage solutions. The cost of storage itself in ADLS is actually exactly the same as the storage in as the cost of normal Azure storage. There is a slightly higher transactional cost in the hot storage tier, where for every 4 megabyte per 10,000 transactions, you pay 0.05 versus 0.04 pounds. So there is a slightly higher transactional cost, but it's only in hot storage and is, for the amount of extra functionality you get, I think it's fairly minimal. And still, even with that slightly higher cost, it's an extremely cost-effective storage solution. Also worth mentioning lifecycle management. So lifecycle management in Blob storage is how you define how data moves from hot storage as it's sort of newer data which needs constant hot access to it. It can then move into cold storage as the data is older and accessed less frequently, and then into archive storage once sort of you don't need to access anymore. Lifecycle management is also works in Azure Data Lake, so you can move things between hot and cold storage as needed. So this gives you a sort of further cost reduction in storing especially large amounts of data which you don't need to access all of the time. So, focusing in on security, how does ADLS allow us to build a secure data solution? We can't really discuss security in Azure without talking about Azure Active Directory. So Azure Active Directory is Azure's identity and access management platform. It allows you to assign and manage permissions for different entities within your system via role-based access control. These identities are managed using security principles, where each user or application is assigned a principal, which can then be assigned permissions to access certain other resources or applications. ADLS also supports single sign-on and multi-factor authentication for increased security for users within your system. So within Azure Active Directory, or AD, the security principles which represent user and applications are organized into tenants. The principals within a tenant can be given access to different resources which are controlled by that tenant. Tenants can represent an entire organization and allow members to access a huge range of services like Office 365, Azure DevOps, WordPress, etc. Or organizations might have a separate development and production tenant. So this can act as a separate security boundary where people might be given some permissions in the development tenant and not in the production tenant. And so you can sort of partition your resources, or the permissions for your resources as needed. So access to all of the resources, a subscription in Azure, which is what contains resource groups and resources, resides within an AAD tenant, and that AAD tenant will control the permissions to all of the resources inside of those subscriptions. So both people and services authenticate via security principles to connect to the Azure resources within a subscription. The security principles are given permissions within the associated tenant, which define what a service or user is allowed to do. For a user, the security principle is called a user principle. This user will be associated with a user principle in each of the AAD tenants, which control resources that it needs access to. And then for services, a service is represented by an AAD application in its home tenant. So say you could have an Azure Function service, and that would be represented by an AAD application within the tenant within the tenant which controls the subscription that it resides in. You can think of the AAD application as like the physical representation of a service. Then in each tenant for which the service needs access to resources within, it will have its own service principle. So the service principle is like the identity of that application in each tenant. This might be simpler if we look at a diagram. So here we have multiple AAD tenants. There is a service, like Azure Functions, which is represented by an AAD application within its own tenant. The AAD application then has an associated service principle within that tenant, which is that service's identity for accessing resources within the tenant. It might also have a service principle in a secondary tenant, which it would then use to access resources within that other tenant. So the final thing I wanted to talk about in terms of Azure Active Directory is managed identities. A managed identity is basically a service principal without the hassle. You no longer need a separate sort of AAD application to represent your service because the identity is tied directly to the service itself. So you assign the service a managed identity, and then this is used to authenticate to other resources within the tenant. Once it's been created, you can assign permissions to it just as you would a normal service principal. When you set up a functions app, you can turn on the option for a managed identity in the identity section of the platform features. You can do this using either a system or a user-assigned identity. A system-assigned identity is like the easier way to do this, where basically a managed identity will just be created for you. It'll be tied to the service, and so it'll just those two things will be completely tied together, and that identity will just be used to represent that service when it's authenticating to other things. For a user-assigned managed identity, the managed identity is created like as a standalone Azure resource. So Azure creates the identity in the Azure AD tenant. This identity can then be assigned to like one or more services, so you can use the same identity to control the permissions for multiple services. And the lifecycle of that user-assigned identity is managed separately from that of the resource. So you could set up a new managed identity and then assign that to a service, and sort of change the permission. Well, you have a lot more flexibility around the permissions management, which isn't really true if you've got a system assigned identity, because that identity is like completely tied to the service itself. Crucially though, the use of managed identities means that all of the credentials for authenticating as a service is managed for you, and you don't have to store like connection strings to tell the functions app which AAD application to use for authentication, because the service is like directly associated with the identity, rather than the service needing to be told which AAD app is representing it. Okay, so using AAD and some of the other features we've already talked about, how does Azure Data Lake allow us to support some well-known security best practices? Here are some well-known practices, and we'll go through how ADLS supports each of these individually. So the first one I want to talk about is the principle of least privilege. So the principle of least privilege means that you are enforcing restriction of access to the minimum required for each user or service. It also means limiting as much as possible the amount of human users which have access to the data, because each additional human user represents an extra sort of risk of exposure. As I've already mentioned, AAD allows role-based access control. So within Data Lake, you can apply role-based permissions, such as like storage blob data contributor, which specifically define the access. In a role-based way, specifically define the access to the data. So you might apply a storage blob data contributor permission to a user, and that would mean that that user would then have access to read and write all data. However, there is a different form of permissions for managing permissions within Azure Data Lake. So Azure Data Lake provides some additional security features outside of the role-based claims. Access control lists provide access to the data at a folder or file level inside the data system. It allows you to have a really fine-grained data security model. It's POSIX-style security, which means that permissions are stored on the items themselves. Specific identities can be given read or write access at like a file or folder level within the data lake. So these permissions at a folder level can be applied to groups as well as to individuals, and this is really good because it means that you can have, say, like a developers group, and you can assign that group access to all of the development data, and then when a new person starts, or someone leaves, you can just manage the permissions by adding or removing them from that developers group, rather than having to go and individually add them or delete them from the from the access control list at folder level. Permissions on a parent folder aren't automatically inherited. So it can be set up so that new children added to the folder will be set up with the same permissions, but that doesn't happen automatically. So it's harder in that way to accidentally give people access to data that they shouldn't have access to. Until recently, this was another big argument for the use of AAD groups rather than individual identities, as permissions were set on new items at the time of creation. So if you have an existing data lake and you needed to edit the permissions, then you'd have to go and edit those at every single folder or file level. However, a couple of weeks ago it was announced that we will now be able to apply permissions from a parent folder to existing children, and this is really exciting because it means permission management of existing data lakes is so much easier. However, still, I think the management of users' identities which have access to things using groups rather than individuals is the way to go, because it means that the management, so the addition or deletion of permissions is as simple as just adding or removing someone from a group. And say you had to add a new folder which all of the developers needed access to at the top level of the directory, you would then just add that group to the permissions of that folder rather than having to add everyone individually. A couple of things that's worth noting about setting up permissions so that people can access the data within a data lake. Execute permissions are needed at every level of the folder structure down to the nested folder, which people need to read or write, because otherwise you can't enumerate the folders and won't be able to sort of reach the folder that you need access to. Also worth noting that if a user has both RBAC permissions, so if they had the Azure Blob data contributor role, which means they can read and write all data, and also were in access controllers inside the data lake, then the RBAC role would overwrite the access control list and they would have access to everything. So that's definitely worth keeping in mind when setting up the permissions. So an important next step in securing your data through these access control lists is to think about a data hierarchy, a data taxonomy. So a well-defined data taxonomy allows you to organize and manage data, and so this is enabled by the hierarchical namespace features. So you can isolate your data as necessary and silo these off into completely separate parts of the data lake. So this allows greater access control where services can only be given access to the data they actually need to be. And it also opens up governance possibilities where regulations around data access and isolation can be easily met and evidenced. Alongside this, the service-to-service communication via MSIs allows credentials to be managed for you and reduce the amount of human users which have direct access to the data in line with the principle of least privilege. Another well-defined security practice is to encrypt all of your data both at rest and in transit. So in Azure Storage, all data is encrypted at rest and in transit by default. All data is encrypted at rest at all tiers, so hot, cold, or archive, and including all redundancy storage that you have enabled. Data is secured in transit by using HTTPS, and HTTPS is the only protocol that is supported for Data Lake Store REST interfaces. For this encryption, there is the option to bring your own key. To encrypt the stored data. Managed keys are used by default and is generally best practice, recommended practice, but in some scenarios, like for compliance, the ability to use your own key might be a requirement, and this feature supports this. There is also a new feature in Blob storage around encryption scopes. So this is a really great feature where you can basically manage the scope of each encryption key at a blob or container level, and you can create really secure boundaries between data that resides within the same storage account. This feature isn't yet supported by ADLS, but hopefully you should see it soon. So another huge advantage of Data Lake is the support for various compliance-based scenarios. So it allows for a really complex data taxonomy, which allows fine-grained organizational management of different parts of your data, including access control. The application of permissions at a folder level means you can completely silo off sections of your data within the same data lake, which might be crucial for meeting data isolation and compliance needs. Also, I've already mentioned that recently a new preview feature of immutable blobs was announced. This means that blobs can exist in a read-only state, which is incredibly important and might even be a regulatory requirement for some types of data. These immutable blobs can be defined in terms of a retention period, so they'll be immutable up to that given time period, or it can be defined in terms of legal holds, where the immutability will hold for as long as the legal hold is active. So as you can see, that's a huge that can be a huge win in terms of compliance and meeting the needs of your customers. There is also huge support for monitoring and alerting within Azure Data Lake via advanced threat detection. So using the service, threats can be detected and monitored, and alerts can be raised based off this data. Threats can be around sort of location or anonymous access. They can be around unexpected data transfer, data exploration, deletion. You can monitor access control requests, and you can even detect malware uploads. There's a rich amount of support, which is ever expanding as security concerns are better understood, and you'll get all the latest updates without doing anything. So it's all you get the latest technology out of the box. So we have spoken a bit about recoverability at all, but finally I want to go through a few more of these points in detail. So there are several features which promote the recoverability of data, which is massively important, especially in business critical scenarios. And there are also some more features on the roadmap which will greatly improve the support for this really important concern. So currently, diagnostic logging is fully built into Blob storage and ADLS. It allows you to quickly diagnose and monitor failures and reduce the chance of these failures causing long-term side effects. Alongside this, in preview, you can now take snapshots of your blobs. So this is a really good feature because it means that if you sort of regularly snapshot blobs, then you are able to view these snapshots and work out where you were at a given time, which can be really helpful again for recovering or diagnosing failures. You can also now enable soft delete at a container level, which means that you, if you enable this, it means that you have you can be sure that your data won't be accidentally deleted. The support for this at Blob level isn't yet in ADLS, but we're hopefully we should see this soon. So there are more changes in Blob storage, such as the change feed, which I've already mentioned, which gives you a full audit trail of everything up to that point, Blob soft delete, as I've just said, and the versioning and restore, which is obviously a huge win for recoverability. So yeah, these aren't supported yet, but are very much on the roadmap as features which should be coming soon to ADLS. So finally, I thought I'd just give a quick example of all of this in practice. So say we had an Azure function which needs to read and write data from two separate folders within a data lake. That function connects to Azure Active Directory via its managed identity. And the managed identity is being assigned the necessary permissions within the data lake. This scenario is fully supported because you could have an Azure function with a managed identity. That managed identity could be given read access to a single folder and write access to another folder, and therefore that it would only have the ability to access the data in the way that it needs at a folder level within the data lake. So I just want to show you what some of this looks like in practice. I've got a simple function which I can show you having access and not having access and how that works in terms of the children of different folders within the data lake. So I've got here a really simple function. It just reads data from a specified blob. So basically through the request, you just specify the blob that you want to read. So this is using the new Blob SDK, the one which speaks both to Blob storage and to Azure Data Lake. So we can speak to the Azure Data Lake account. So yeah, you just specify the file you want to read and it goes to download the content of that blob and returns that as part of the request. It's using the default Azure credential to authenticate. This will try and authenticate in a few different ways, using the environment variables and using the local settings file. And so if you don't specify a connection string in these, it'll use the managed identity by default. I'm also using interactive browser credential here, just this is for local development, so I use it when running the function locally. So yeah, really simple function, and this is now what's deployed into Azure. So this is what will run in Azure if we hit this endpoint. So here's the function, and if we go into the identity section of the platform features, we can see that this function has a system assigned managed identity. So this is what will be given access to different folders within the data lake, which will allow the function to then access the data it needs. So if we then go into the data lake and go into Storage Explorer view in the portal, we can see that we have some folders set up. inside the data lake. We've got sample 1 and sample 2 folder. If we manage the access for the sample 1 folder, we can see that the managed identity for the functions app has been given read and execute access, and these have been set up as default permissions, so these will be added to any new children which are added to the folder. So if we then go into that sample folder, we can see that we have a test file. And then we have a sample 2 folder, which also contains a test file. And if we manage the access for the sample 2 folder, we can see that the function app does not have access. So if we go into Postman and hit that endpoint, so this is hitting the endpoint up in Azure. If we specify sample 1 as the folder, which is the one that it does have access to, and if we hit that endpoint, we can see that it reads out the contents of that file. However, if we go to sample 2, and again hit the endpoint, we will get an internal server. It would obviously be better to do error handling and return a non-authorized error code there, but for simplicity in the function, I've left that for now. So if we go into Storage Explorer, and into the sample 1 folder, and we upload a new file into the sample 1 folder, and remember this folder has been set up with default permissions, then the new file will be given the same permissions as the parent. So if we upload that, and so if we go into here, we can see that the function app has been given the same read and execute permissions on the child file. So if we go back into Postman and we update it to try and read the contents of that new file in the sample 1 folder, then we should see the contents of that file returned. We do. So, however, if we go back into Storage Explorer and we instead go into the sample 2 folder, and if we set up new permissions on sample 2 folder for our managed identity, and we give it access, so read and execute access at the folder level, but don't give it default access, so this won't be applied to any new children of the folder. We can see firstly that the permissions haven't been added to the file inside of that folder, and if we upload a new file to the folder, we'll just upload the same file as we did to the other one. If we upload a new file to that folder, then again we can see that those permissions haven't been added, as we haven't set them up as default permissions, so they've not been added to the new children of the folder. And still, if we go and change it so that we are setting up default permissions, so ones that will be applied to the new children, as I've said a few times, these permissions are only added to new children. So still, if we go into the folder, we can see that those have not been added to the child. So a quick sort of demo of how that all works in practice, that just about wraps up everything I have to say. So this has been a talk about how to set up a secure data solution using Azure Data Lake. I hope it's been useful and demonstrated some of the powerful features of Azure Data Lake, and talked about some of the new features which we should hopefully be seeing in the near future. I've been Carmelie. You can follow me on Twitter, LinkedIn, etc. And I hope I'm around in the comments, and presumably have been for the rest of this talk. So send over any questions, and thanks for listening.